Okay, the last thing we're going to talk about in our chemistry unit is mixtures. So our essential question for today is, what are some physical properties, that's what the P stands for, what are some physical properties of mixtures? So this is learning target 44. You're going to use the particle theory of matter to classify mixtures and compounds. All right, so a compound, which we've been working with, we've learned how compounds can be formed. That's where elements chemically combine. Remember, they can combine ionically, covalently, or metallically during a chemical reaction in fixed proportions. So remember, we just finished talking about chemical reactions, how you have to have a certain amount of collisions in order for those elements to combine. And they're always in fixed proportions. We learned about this on how compounds can form, because two hydrogens will bond with one oxygen. Okay, always two hydrogen, one oxygen. That forms a covalent bond. It has to go that way. Cannot be separated by physical means. So you can't separate compounds physically by evaporation. You have to use chemical means, which is usually another chemical reaction. So you have to have an extreme amount. You have to have a lot of energy to separate compounds. Now, a mixture is a combination of either all different elements, combinations of different compounds, or it could be a combination of elements and compounds. And those elements or compounds are just floating around together. They're not bonded. They're not in fixed proportions. For example, lemonade. Depending on how you like your lemonade, whether you like it strong or weak, you're going to have different amounts of sugar versus water. Okay, so it's not fixed proportions. And you can separate a mixture by physical means. We could evaporate the water. It'll leave behind the sugar. So that's a review on the difference between compound and mixtures. So we classify mixtures as two types, heterogeneous and homogeneous. Heterogeneous mixtures are substances that are not evenly mixed, and you can usually see the parts in that mixture. So like in cereal, you can see the different parts of cereal, you can see the milk. Pizza, you can see the different parts of the pizza, pepperoni, cheese, olives, bread. Sand, you take a handful of sand, you can see all the different colors of the different types of matter that makes up sand. A homogeneous mixture is when substances are evenly mixed. They're called solutions, and they are hard to tell what's in them. For example, one that I definitely want you to put down that I forgot is brass. Remember, brass is a mixture of copper and zinc. Okay, so copper and zinc will make a mixture of brass. Now you can't see the different copper and zinc inside the brass because they're all mixed evenly. Same thing with lemonade and milk. So one thing I want to show you is this idea of how solutions are made. So if I shake the salt, those are salt compounds being dropped into water. Now notice, the water will pull apart the salt, the sodium chloride. Okay, that's why you see the green and pink are now separated. So they no longer are in compounds, they're in the elements. Okay, so a solution does that. That's what a solution is. And we'll come back to this a little bit later when we talk about saturated. Okay, in a solution, we have what's called a solute or a solvent. A solute is a substance being dissolved. So in the example of lemonade, sugar is what's being dissolved. A solvent is a substance that does the dissolving, which is usually water. So in lemonade, water dissolves the sugar. It's the universal solvent. So that's the difference between a solute and a solvent. Some rules on what will dissolve and what won't. So like dissolves like. So polar will dissolve polar or ionic compounds. It has to have charges to be able to dissolve. That's why water, which is a polar compound, will dissolve salt, which is ionic, because there's charges there. Polar and nonpolar will not dissolve, because remember, nonpolar covalent bonds do not have charges. So water can't pull them apart, like I showed you in the example. So when you mix oil and water, oil won't dissolve in water. Oh, I don't want to do that. Never mind. Now, solubility is what determines how much solute dissolves in a solvent. So you have what's called a saturated solution. A saturated solution contains all the solute that it can hold. So that means no more will dissolve. That would be like 100% humidity. The the air is containing all the water that it can hold, and that's a saturated solution. So obviously we don't have that here a lot. Okay, that's all I wanted to go over. So I'm going to show you what that looks like. So if we look here, the solute is the salt, the solvent is the water. If I keep shaking and I keep adding salt, eventually there won't be enough water to dissolve the salt. Okay, so right now, I think I'm going to have to add a ton. The water is able to dissolve all that salt. I'm almost close. I'm pretty close. Okay, so you see how solid salt still forms at the bottom? That means I went over the saturation amount. Okay, so saturation is where water has dissolved all the salt it can. You start adding more salt to the water, it becomes super saturated. That means the water doesn't, there aren't enough water molecules to dissolve the salt. And that's why the salts will clump together. Okay, so that is a review, because we have covered these terms before in 6th grade. That's a review of mixtures versus compounds. And remember, the particle theory of matter talks about whether matter can be separated or not, whether it's a pure substance or not. Remember, compounds and elements are pure substances. You can't break them down. Mixtures can be broken down.